5-2. I would say a short name would be something like parallel lines, but slightly longer. If the angles are, fill in the blank, there's two blanks you could fill in here, either congruent or supplementary, then the lines are parallel. There are about 6 theorems with this content. It seems kind of daunting, but it isn't. I'm going to draw you a little picture here, and that is a good way to summarize the whole unit. So you've seen this before, alternate interior, corresponding exterior. Before we do that, there is one theorem right at the very beginning that gets lost. It's a rule. Okay, not too sure why they call it a theorem. We never really quote it that I can remember of. Anyways, so the exterior angle of a triangle. Yeah, let me highlight an exterior angle that they did right here. Yeah, is congruent to the two remote angles added together. So here is the remote interior. Yeah. And I'll call them remote 1, remote 2. All right, so if I add up those two remote angles, it will equal that exterior angle. Kind of cool. One of the reasons is, I guess the most obvious way to see is that these two form a linear pair. They're supplementary. We all know that if you are in a triangle, right, these three angles have to add up to 180. So then these two have to be the same as this one. All right. That's a little visual. I'm not going to go through the proof of that. It isn't a complex proof. I'm going to quickly go through the 6 theorems, and then you'll get a gist of them. All right, if the corresponding angles, again, should we sketch quickly the corresponding angles? So here we have parallel lines, there we have the transversal, yeah? All right, corresponding angles that are in the same position. So for example, this angle and this angle. If those angles are congruent, then these two lines are parallel. AIA, if the alternate interior angles are congruent, then the lines are parallel. Again, alternate interior angles, that would be like this one and this one. Excuse me. Okay? Then this line, it'd be parallel to this line. If the alternate exterior angles are congruent, then the lines are parallel. If the same side interior, all right, are supplementary, then the lines are parallel. And let's look at a picture of this. So here are my two lines. Here's my transversal. And now I go and grab the same side interior, right? So if those two add up to 90 degrees, then this line and this line have to be parallel. If the same side exterior angles are supplementary, then the lines are parallel. Finally, if two lines are perpendicular to the same line, so here we have a line, and now I've got two lines which are perpendicular to it. Yeah, they don't even need to be on the same side. Then these two lines have to be, you guessed it, parallel. All right, so those are your 6 proofs. They all end with lines are parallel. And here's how you basically use them. They're going to have you prove things like this. Something is a parallelogram. So what do we know about shapes that are parallelograms? Well, they have both pairs of opposite sides parallel. Okay, so I need to show this and this, and then I need to show this and this. Okay, so I've got to show double parallelity between opposite pairs. All right, we are given a pair, but notice this is not an indirect proof. Okay? I wouldn't start off with PQRS is not a parallelogram. You could. It would probably take you just a titch longer in some cases. And we're given that those two angles are congruent. Now notice PQR is the big angle here, and RSP is the big angle here. It's the obtuse angle, if you will. All right, they're saying those angles are congruent. Well, if 1 and 2, are congruent, then, and I know that PQR and RSP are congruent, then I can say by angle subtraction, angle 3 and 4 must be congruent as well. Okay, if angle 1 and 2 are congruent, right? So here's my transversal, here's my parallel lines. So I can say PQ is congruent to SR. And again, now I have to go back. Sorry. What did I say? PQ and SR. Now I have to go back and look at the other sides of the parallelogram. Can I show QR and PS? Why, now my transversal's still there. Now I'm going to use 3 and 4. And again, I know that they're congruent. So again, SQR and PS. All right. And finally I say, oh, and this would be the alternate interior angles theorem. And this would be the alternate interior angles theorem. And why is PQRS a parallelogram? Because by definition of parallelogram, they told us right above the problem, oh, a parallelogram is a band. Okay. Good luck as you work through section 5.2, proving things are parallel.